Hello, my name is Frank Thier, and this is my object-oriented design explanation video where I'll be talking about this week's coding challenge scenario. So our mission was to design a dealership that handled a variety of vehicles to match the customer's needs, such as cars, pickup trucks, and SUVs, each having a unique feature being both 2- and 4-door for cars, the pickup trucks having cargo space, and SUVs having a towing capacity. When the customers came to the shop, they usually had one of these vehicles in mind, but they were also interested in other options or features such as number of seats, leather versus cloth, car color, and sunroof. They wanted to know the price, how many miles are on the car, the manufacturer and model, and then choosing an electric or hybrid car was also important. So we used a development system called test-driven development, and we've been basically doing this for every coding challenge up to now and for the foreseeable future probably, where the tests are actually written first, right? So instead of writing the code first and then writing tests to test the code, you write the tests first and then design your code around the tests, right? And it actually makes a lot of sense to do it this way, and it's probably the better way to do it, because then if you design your code around the tests, you know it's going to work exactly how you want it to, and there won't be any crazy behavior going on, right? And then we also used a design pattern or design system called top-down design, which interestingly enough kind of mimics our UML diagrams, right? So you can see here that at the very top we have the vehicle base class, and then the option class gets aggregated into that because it has the option array. And then from there we extend it down to car, pickup truck, and SUV having its unique features. And then to take it even further, we extend from car down to gas car, hybrid car, and electric car, which have unique features of their own. And then hybrid car would implement both a combustible and a chargeable interface, right? So, like I said, first we started with the vehicle class, which is right here. And the vehicle class has an array of options, and that will get passed down to every class that extends it, right? And then it also has the manufacturer name, miles, price, number of seats, and options, which are all things that the customer wanted to know about the vehicle. And then we start working our way down. So we extend the vehicle class and we make the car class, which has its unique feature, which is the number of doors. The pickup truck, where did that go? Right here. The pickup truck, which has its cargo capacity. And then of course the SUV, which I need to get a bigger screen, which has its unique feature of max towing weight, right? So we've extended vehicle down into these 3 subclasses, and then we're going to extend car down into its 3 subclasses, which are gas car, which is right here, which implements the combustible interface, the electric car, which implements the chargeable interface, and then the hybrid car class, which implements combustible and chargeable. So these classes all have the option array because the vehicle class has its option array, and it passes that down through inheritance to each subclass. And when we get to hybrid car, it has the option array and everything that a regular car has, and then it adds its unique features right here. And so here's where polymorphism becomes super interesting, because let's say that combustible and chargeable were not interfaces. So, for a car to be combustible, it has these 2 methods. It has to fill up its gas tank and then return its fuel level. And then the chargeable interface charges up the battery and then gets its battery charge, right? And so for a hybrid car to be both combustible and chargeable, it wouldn't really work if these interfaces didn't exist, right? So let's say that we have gas car, right? So gas car is combustible, but it's not chargeable, right? And so if we put combustible in the car class, chargeable wouldn't make sense to go in the car class, so it would have to go in electric car. But then when we create the hybrid car class, it wouldn't be able to be both, right? And so this is the polymorphism, where you can say that your object passes the is a test for two different cases, right? So hybrid car is a car, but it's also combustible and chargeable, right? And so because the combustible and chargeable are interfaces, we can create any subclass of car that we want, and it can implement those as we need it to. Versus if these were tied to classes themselves, that would not be possible, right? Because hybrid car has to have both, but you can't extend to different superclasses, right? And so that's the polymorphism right there. And so I hope you understand a little bit more about polymorphism, inheritance, and how the design process overall comes together to accomplish a certain scenario or a certain goal. If you have any questions, please leave a comment, and thank you again for watching.